Hello guys, how are you? I'm back again with a new video in introducing a new concept of Java programming. So the new viewers who haven't seen my last two videos about Java programming, please go through my channel and you can find the playlist of Java programming so that you can watch those videos and come to this video. So in first video, I have explained the introduction to the Java programming and a brief content about how Java works and all, and comparison with C language. And in second video, I have explained the concept of compiler and concept of interpreter and the differences, and how a human readable language English can be converted to in a language converted to a language that machine understand, which is machine code. So what is the process between what is the process that I have done by the compiler and interpreter. So we have not any code related stuff in those videos. So in this video, the agenda of the video is to understand better about the hierarchy, JDK, JRE, JVM, and we are going to do the first program, and installation of Java program will be Java development kit will be done in this video. So are you ready for this concept? So let's move into the concept. So let me recall the previous video that I have explained about compiler and interpreter differences. So compiler means it executes the entire code in at a time once. Compiler executes the code line by line. So if you want a detailed explanation, you can go back to that video and see that video. So in Java programming, that I have mentioned in every video of my playlist, that Java is both compiled and interpreted language. That means if machine wants to understand the Java code that I have written, because I have written something like to print hello world. To print hello world, I have written a Java code. To make system understand that statement, understand that command, I have to compile it first. So first I compile the Java programming, Java code, and then the code will be converted into, and the new class file will be generated. That class file has bytecode and some other related libraries. So a class file is generated. Using that class file, we interpret every line of the bytecode, and then see the execution of the program. So this is how Java is both compiled and interpreted language. So let me go into this video concept, where the problem statement is Java code runs almost everywhere, because Java is a platform independent language, because that class file can be shared to any operating system. Like if you share that operating system to, if you share that class file to your friend will get output. If you share that class file to other operating system like Linux in other area, in other place not related to this location also, that it will get executed, because Java is a platform independent language, where in C language .exe file is generated after compilation. Dot, .exe file is aligned to the operating system, aligned to the CPU configurations of that particular system only. If you share that .exe file to other system, it won't work, because C language is not a platform independent language. So if you are clear with this concept, so we will get more details in this video. So Java code runs almost everywhere, but it's not directly compiled into .exe file like C. Yes, obviously we have discussed it earlier. What's the magic behind it? So when we see the big picture of the concept, let me introduce this JVM, JRE, JDK as foundation pillars of Java ecosystem. So what we will cover is clear. So we discussed about the concept like write once, run anywhere, which is the concept of platform independence. So let me share the more details about JDK. So we have three concepts here. Java, treat like Java is like an environment. So you want to execute, you know Java programming, but you want to execute and run the Java programs. So if you want to run, you need a Java software, right? So like you can't run something without a software. So you need to install Java. So before installation of Java, we need to be clear with these three concepts like JDK, JRE, JVM. JDK means Java Development Kit. The definition of JDK is the JDK is a complete software development kit. It's SDK for Java. It's what developers download and install, write, compile, and run applications. It's full package for development. So, if you are developing a Java software, if you are writing a Java code, you need some particular environment, right? If if you are living in the house, you don't need construction work skill, but you are building house, you need construction work skills and other tools to build that construction. So if you are engineer, you are building something, you need more skill, you need that building constructing skills, and you need some tools. But if you are living in that construction, you don't need anything, you just live in that construction, right? So when you are developing this Java, you definitely need this Java development kit. So analogy, like if you want to build a house, you need the full toolkit, blueprints, like for example JRE and all construction tools like compiler, debugger. So you need everything related to Java to build something. You need everything related to Java to build something. So what's inside JDK is Java runtime environment. So JDK is a superset of JRE. So JDK contains JRE. JRE means Java runtime environment. So it was an environment to run Java applications. Crucially, JDK includes JRE. So the point is very clear that JDK has JRE. JDK is superset of JRE. This means if you have JDK, you automatically have everything needed to run Java program. So if you have JDK, you already had JRE. So what are development tools that JDK has? Java C means Java compiler. So to check errors, to compile into that bytecode, first we need to proceed with the compilation process. So you need a Java compiler for that. Takes your .java source code, which is written like if you are writing to print hello world. So that was your source code. That if you that takes your Java source code and compiles it into platform independent Java bytecode, which is .class files. Next, Java, which used to run Java application. It launches a JVM instance. So that means JDK contains JRE and JVM also. So used to run Java applications, we need Java application launcher. For debugging, we need Java debugger. For documentation generating, Java doc we need. Java archiver, we need jar tool to package multiple dot classes file and associated resources into single jar file. So you have multiple jar class files, you can associate into single jar file. So other utilities like JLink, JStack, JM, JCMD for advanced monitoring and analytics. When you go to advanced Java development, these tools will be used. So remember that for developers who are writing, who are creating, who are developing that Java programs or software needs JDK kit for sure. So what is JRE then? Java Runtime Environment, which is also present in JDK. So in JDK we have JRE also. Why do we need to particularly concentrate on JRE? Because JRE is a software package that provides minimum requirements for executing a Java application. If you only want to run Java programs, you need only JRE. You don't need JDK. If you want to develop Java programs, we need JDK. So coming to the analogy of this concept, if you want to live in a house, not build it, you haven't built that, you don't build that home. You are not a constructor, you are not an engineer. If you want to live in that home which is not built by you, you just need a completed house with utilities, which means a fan, fridge, TV, AC, something, all the tools. Not construction tool. You don't need a construction skill. You don't need a construction tool like that you use in construction works, right? So Java runtime is only to run. It's an environment that is able to make you to execute Java programs, but not compile Java programs. You have only Java. So what's inside JRE is JVM, Java Virtual Machine, the core component that executes Java bytecode. So this Java Virtual Machine will execute Java bytecode, not Java source code. So Java source code can be Java source code can be converted into Java bytecode. Java bytecode will be converted into output. So this conversion of bytecode is not done by the Java runtime environment, because those who are compiling one code, they are they are the developer. Only developers will compile the code. Only if in runtime environment you won't have Java compiler. In Java development kit you have runtime environment and compilation. So in so here we have Java compiler, so that it Java source code compiles into bytecode. So this will be available in JDK, and in JRE we will have JVM, Java Virtual Machine, the core component that executes Java bytecode. So in runtime environment we need that is environment to run applications. So we have some Java applications, Java libraries, APIs, the vast collection of pre-written reusable code components that provide standard functionalities. These are organized into packages: Java Lang, Java IO, Java Util, which is used in our programming, which is imported during the programming, where we use other packages, classes, predefined classes and interfaces to enhance our programming out uh, pro- output. These libraries are usually bundled into rt.jar runtime jar. Jar means a group of dot classes files combined associated into single file. Modular in newer Java versions. So when coming to the Java runtime environment, it's an environment to run Java application. Java.jdk means it's a kit that has runtime environment and that has compilation ability and other tools. So let me explain about a clear picture of JVM now, which is heart of Java. JVM is an abstract machine, a specification for a computing environment that executes Java bytecode. It's virtual processor that understands .class files. So we have a JDK. We have a JDK in a machine. That JDK has Java compiler. So developer compile that code and convert it into Java bytecode, which is .class file. That .class file got shared into other machine, other computer, where it has only Java runtime environment but not JDK. So they will directly execute that. They will directly run that .class file. They will see the output. So this means here we are using the facility of the platform independence. How it can be platform independence? In C language, after compilation, we get .exe file, right? After the generation of .exe file, that .exe file is aligned with that particular CPU configuration only, that operating system and CPU configuration only. When we share the .exe file, it won't get executed just because of its platform dependence ability. So here that particular issue got solved because of this JVM. JVM acts as virtual processor, and it acts as virtual CPU for that uh, Java programs, so that it will be considered as virtual processor for Java program. So it is standard and it is same for every program, every machine. If if a machine get installed with JRE means it has JVM. So in every machine which had a JRE or JDK has same JVM, same environment, so that it can be executed in any environment. You understand the concept? That in C language we are facing this platform dependence issue just because of CPU aligned .exe file generation. So it is aligned to the CPU configuration. So to avoid the issue in this Java, so every CPU will have we should have the same configuration, right? But it is not possible. So we are considering this virtual processor that has same configuration across all the machines. It's an abstract machine, a specification for computing environment that by executes bytecode. It's a virtual processor that understands .class files. So JVM is a specification like blueprint for processor, and various companies provide their own concrete implementation of this specification. So various companies will provide their own concrete implementation, but the implementation will be same in every machine. JVM is like software computer, software CPU. Yes, this is a point that runs on top of your actual hardware. So it runs as software CPU on hardware CPU. That Java program considers this software CPU and gets executes the program. So software CPU is same for every machine that get installed with that particular Java runtime environment, right? Its translator and executor rolled into one. So core components of Java is Java class loader, which loads the .class files, runtime data areas. There are memory areas that JVM allocates to execute the program. So these are the runtime data areas. Heap, which we store our objects and instance variables. JVM stack one stores method calls and local variables one particular result. So in detail, these concepts will be explained in further videos when we are discussing about the primitive data types and other data types. So execution engine, which is a brain of JVM, which contain interpreter and just-in-time compiler. In previous video, we have discussed about this just-in-time compiler. So just-in-time compiler used in Java to improve performance. When a hotspot is found, that repeated work is found, it get compiled. So to improve performance, JIT identify hotspots, frequently executed bytecode sequences within a loop. It compiles these hotspots into optimize the native machine code during runtime. That native machine code is then cached, and subsequent executions of that hotspot use the further native code. So this is the point I have already covered in this in a previous video. So why JIT is crucial to performance enhancement. Garbage collector, that means it's a memory management concept. Uh, During the application of garbage collection in code, when we are going to programming hands-on part of the Java programming, in any concept that has this concept, in any particular video that has this concept which is written in the code, I will explain you clearly about the garbage collection, but I'm reading the definition now. An automatic memory management system, it identifies and reclaims memory occupied by objects that are no longer referenced by the running program, preventing memory leaks. So it is an automatic memory management system where developers don't need to manually manage memory. Actually, in C language, we will use malloc, realloc, like dynamic memory allocation keywords, but here we don't need that. Our memory will be automatically managed by the garbage collector. Java native interface allows Java code to call and called by native applications and libraries written in other languages. So when we want to call and get called by native applications and other libraries written in other languages used for platform specific functionalities or performance critical tasks that can't be done effectively in Java. So when those libraries or functionalities that are better in other language, we can use those. We can call those libraries. written in other languages using this Java native interface. So, so in this picture we will understand that JDK, which has JVM, JRE. In JRE we have JVM. So JDK, that JDK means your analogy, coming to analogy, you are an engineer who is building a construction with some development tools. So Java compiler comes under development tool, because a layman who is just using the Java program, or who is just executing a Java program, need not have the use of Java compiler. Only a developer who have developed the program to convert into byte class file, they need Java compiler. So Java C will be there in JDK only, but not in JVM or JRE. So JDK contains this development Java runtime environment and development tools like Java C, Java, etc. So Java runtime environment has these those particular libraries that JVM, and those particular libraries that required to execute Java packages or Java libraries. So JVM, which is the heart of Java program that converts bytecode into output, which has JVM has that interpreter, just in compiler, and those the concept that we have discussed now, just in compiler, garbage collector, and Java native interface. So, like practical, when coming to the practical analogy of these concepts, the car's machine, the car's engine does the actual work is a JVM. That means we are converting that bytecode into output. The car itself is in runtime environment. So you are driving a car, but you are not building a car. You are not in preparing a car. So you are using your car. You just need to know driving, right? You don't need that building car to that skill or tools. So you just need the skill of driving and the parts that required for driving. So car itself is a runtime environment. But coming to JDK, the car plus tools in garage that can able to prepare that car or repair that car, wrench sets, diagnostic tools, spare parts, everything to build, repair and drive cars required is together called as development kit, where just driving a car with all the utilities is runtime environment. Just engine which is responsible for that runtime is Java virtual machines, which is heart of Java. So why this modularity is platform independence? For security, because Java JVM acts as sandbox, providing a layer of security controlling what Java program can do. So preventing direct memory access. So automatic memory management is garbage collection, which we are going to discuss in further videos in detail, where we are getting the concept in hands-on. Performance, JIT compilation bridges the gap between interpretation and native compilation, offering excellent performance, because we are identifying those hotspots where repeated bytecode is find out, and that bytecode will be converted into native compilation, and that that enhances performance. Ecosystem and library, Java has an extensive community support and have extensive Java class libraries, reduce boilerplate code and speed up development. So forward compatibility, newer JVMs can often run older bytecode, maintaining backward compatibility. So, so if you all got, I think all got clarity about this Java development kit, Java runtime environment, and Java virtual machine. So in first video I explained about Java and comparing Java with C language, and all these concepts are briefly explained in first video, and in second video of my playlist I clearly explain you about what is compiler and what is interpreter and the differences between compiler and interpreter, and then came to the concept of how Java how Java is both compiled and interpreted language, and I gave introduction about just in compiler, but we have not done anything that related to code up to now. So we are developers, right? We are creating that code. We are not executing the Java program. We are now creating the Java program. So we need now, what we need in our system now, we need development kit. So let's install Java development kit. So how you go to the Google Chrome and go to any browser in your system, that please type JDK download. So I have explained you in the previous videos, right? Java is first developed by Sun Microsystems and then acquired by the Oracle. So you go to this first website you are getting in the browser. So Java downloads. So uh, we are writing code, right? So we need JDK development kit. So go to Java downloads. So Java SC development kits downloads. So my operating system is currently Windows. So go to x64 installer. Well, because my operating system is a 64-bit operating system. So install this and then download this and install this. So I have already got installed with my Java now, Java. So I am opening my command prompt. So my command prompt is in a folder in the C drive users folder and Ganesh, which I am opening in this file explorer. C drive users Ganesh folder. So here I am creating a folder for my Java applications. That let me name that folder as Java or else oops. So in this folder I have created a oops folder. In this folder I have created, let me change my directory to oops, because in command prompt we can access only the folders that is pointing in the command prompt. So if I able I if I use this command dir, I will get all the directories, all the folders which are in that folder, right? So I want to change my directory to oops. My oops is located here. So I am changing this directory. So cd space oops. So I am in oops folder now. When I use dir, I don't have any files right in dir. So no file is showing. So let me create a Java program here. I'm creating a text document to write a Java program, a sample text document. So I open this text document. So let me write a basic hello world program, and this program execution part will be explained here. And what is hello world program? How we are writing code, and everything related to code will be explained in next video. So public class. So else class first public static void main string args system dot out dot println hello YouTube. So this is my basic Java program to print hello YouTube string. So what is class, what is main, what is public, what is static, what is string, system dot out, what is this nonsense? You might get this out, right? So everything will be explained in next video. So this is a program. Just remember that this is a program that can able to print hello YouTube string on my command prompt or my console. So let me save this file because this is text file, right? I need to save it as Java source file. So to save this, my class name should match with my file name. So first dot java. So always my class name should match with my java file name, and it is not text document, so I am changing my save type as all files. So I saved this program and closing this. So I have this. I am deleting this. I have this file first, which is a Java source file. So let me just compile. So I already have a Java, right? Let me check this Java. So I have Java software already got installed in my system. So to compile this, I need to use Java C, which is Java compiler. Java C. I am giving my first dot Java. So here I am not getting any errors get shown. So it is successfully compiled. So dot last file is generated here, which is bytecode. Now my first step is completed. I compiled my Java program using Java compiler in development kit. The dot class file is get generated. Now I use the dot class file to my Java launcher. So Java space first. So I don't know, I don't need to give this dot class extension. I'm just giving this Java first. So I can able to see output in my console, which is command prompt. So I have something for you. So in VM workstation, I have an Ubuntu software. I have an Ubuntu operating system where in the Ubuntu operating system I have only Java runtime machine, runtime environment, but not Java development kit. So let me, I told you right, to 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 develop a code, we need a Java development kit. To run a code, we don't need Java development kit. We don't need a Java development kit. The Java what the runtime environment is enough. So in this operating system, I made Java runtime environment got installed before this video itself. So let me check CMD. So okay. So when I check Java, so in downloads, I have my files. So when you see those files, it's hello.java, which means, so let me show this hello.java. I made this got saved. So hello.java, which is a program that can able to print hello world. So in Windows, I have done that two commands, Java C space first.java, which is in Windows. I have done that. Next Java space first. For compilation Java C, right? Now I told that if this operating system doesn't have Java development kit, this operating system has only JRE. Only I installed JRE in this operating system. So when I use Java C hello.java, it is telling me that Java C is not found. But I shared a class file which able to print Java from that operating system, from Windows operating system. I shared that class file to this operating system, which can able to print hello world. So now I use Java space first directly. It can able to print hello world, but it can't compile hello.java because it has only runtime environment, not development kit. So this is how Java programming is a platform independent language. When a class file is generated, that means that class file works everywhere in any machine with any environment. So this operating system has a runtime environment but not development kit. So we can't compile but we can execute. But we are coming to Windows operating system. I have both the runtime and I have a development kit, which means I have JRE and also JVM. So the execution of Java program is this. We are using two commands. First, we need to move our command prompt to the folder which I saved my Java program. So then I need to use two commands for one for compilation, two for interpretation to execute the program. First, I am using Java C, that my source code. I am giving my source code first.java to Java compiler. Then it is checking errors. If there is no errors, it is then giving me a class file where class file has bytecode. So those bytecode will be interpreted as output using Java launcher. So Java C compiles source code into bytecode. That the Java uses bytecode to produce output. So this is how we use to execute this Java programming. So coming to the concepts that we have discussed, coming to the conclusion, we have discussed all these concepts. I will share you this PDF in the comment section. I have and one more thing, that I have mentioned a WhatsApp channel of my YouTube channel related to my YouTube channel. So if you are interested to get updates regularly and get shared with the latest technology stuff and course related details, so please join if you are interested. That's what I am going to say. So these are the things that we covered today. So if you have any doubt, please comment on this video. And if you like this video, you can share to your friends that who is struggling to understand these concepts. Yeah. So in next video, I will be purely on hands-on. I am going to explain you about object-oriented programming, what is class, and why we are using those terms like public, static, void, main, string, system dot out dot print. Those all the things will be explained in next video. So next video will be brief introduction on OOPS concepts, and why we shifted to OOPS object oriented programming, and then and the detailed explanation of the hello world program. Next video will be purely on hello world program basis only, and then in further videos we move on to the purely Java programming related stuff. So thank you for giving me that your valuable time. Thank you.